Today's lesson we are going to look at Mathematics 16.1.3. The topic for today is related rates. We are going to look at practice questions, lesson 102. Let us start. Now remember, lesson 102s in most cases, they are practice questions. Before lesson 102, you watch lesson 101, whereby we go through the basics. We show you how to actually apply certain equations and how to look at the keywords. And then lesson 102 is when you master a certain chapter. So for each and every question that I'm going to display, you simply pause the video, you work out the question, and then you play the video to verify your answer. The scenario in the question says the SA surface area of a sphere is changing by 36 centimeter squared per second when the radius of the cylinder is 3 centimeter. Find the rate of change of the radius when r is 3 centimeter. Looking at the picture form of this question, we have something like a cylinder, not a cylinder, mean a sphere. We know what is a sphere, and then it has a radius which is 3 centimeter, and then we know the rate at which the surface area is changing. D surface area over dt, that is the rate of the surface area, is 36 centimeter squared per second. And then we need to understand what the question actually requires. Find the rate of change of radius. So it means we are looking for dr over dt, that is the rate of change of the radius. Now in related rates, we should always keep in mind that we are dealing with derivative. We are deriving equations of a certain shape. So we need the shape of a sphere. In most cases, the keywords in the scenario are given. These keywords will actually indicate which equation we should use. So in this case, it says the SA, the surface area. We need the equation of a surface area of a sphere. Now the surface area of a sphere is given by this equation. So it's very important for us to actually know different types of shapes with their equations. Since we have this equation, we can find its derivative. We derive both sides. So the derivative of SA, it will be dSA over dt. Then the derivative of this, remember, we take this as a constant, so we have 4 pi. The derivative of 2r is, r squared is 2r. And then since we are deriving in with respect to dt or time, we need to put dr over dt. Then when we simplify this, we have dsa over dt, it's equals to this multiplied by this, we have 8 pi r dr over dt. Now after deriving, we can see that the question actually asks for this. So from here, we can divide both sides by this to make this the subject of the formula. So it will be dSA over dt divided by 8 pi r, it's equals to dr over dt. Now from the scenario, we are given this. We have the rate of change of the total surface area of the sphere. We also have the radius. So we can go ahead and substitute dr over dt, it's equals to, we are given the rate as 36 divided by 8 pi. We are given the radius as 3. Then dr over dt, it's equals to 36, 8 multiplied by 3, it's 24 pi. Remember, without the use of calculator. So the number which is divisible into 36 and 24, it's 12. 36 divided by 12, it's 3. And then 24 divided by 12, it's 2 pi. So this will be the rate, and then the SI unit, it will be centimeter per second. In order to actually work out the SI unit, it's pretty much simple. Now let us look at this step where we substitute 36. Remember, 36 is measured, it was measured in centimeters squared per second. And then the radius, this radius, it's in centimeters. So you can see that this centimeter will get rid of 1 centimeter, and then whatever that is left is the SI unit of this, which is centimeter per second. Our next scenario, our next question, it says how fast is the parameter of a circle increasing when the area of the circle is 9 centimeters squared and the area is increasing at 18 centimeters squared per second. In this case, we look at the keywords again: parameter and area. So we need to use the equations of parameter of a circle and the area. So if this is a circle, its parameter is actually the circumference, and then we have the area. Then equations of the area of a circle: A is equals to pi r squared, and then the circumference, it's simply the derivative of this, which is circumference 2 pi r. We are given the radius as 9, no, not 9. We're actually given the area, not the radius. It's 9 centimeters squared. And then we look at this, the area is increasing at, so we have dA over dt, which is equals to 18 centimeters squared per second. We are looking at what are we actually calculating? The question requires us to calculate how fast is the parameter. It means it's dc over dt, how fast the parameter is increasing. First thing that we need to do, we need to calculate the radius. We're going to use this equation. We know the value of the area, then we can calculate the radius. This equation, when we solve for r, it will be r squared is equals to a. We divide both sides by pi. Then we take the square root of both sides. We are going to have a over pi. And then this is equals to square root of 9 over pi. We get that the radius is 1.693. or let us actually round off to 2 decimal places, centimeters. So we have 1.69 centimeters. Then from here, let us take the derivative of this. We have a is equals to pi r squared. We derive both sides. We are going to have dA over dt equals to the derivative of this. This is a constant. The derivative of this, it will be 2r dr over dt. Then from here, we are calculating this. That's what we are after. So dA over dt, we have the rate of the area, which is 18 centimeters squared. Then we have 2 pi, the radius is 1.69 dr over dt. So we divide both sides by this. This will get rid of this, and then we are left with this. We need to calculate this. (18) divided by 2, it's simply 9 over 1.69 pi. Then this will be centimeter per second. Now we have the value of dr over dt. Let us go to the equation to calculate the circumference. We need the derivative of this, so it will be dc over dt equals to, this is a constant, the derivative of r is 1, so you have 2 pi multiplied by dr over dt. From here, dc over dt, it's equals to 2 pi, and then that answer is 9 over 1.69 pi. That is the value of dr over dt. We can see that this will get rid of this multiplied by 2, and then dc over dt is equals to 18 over 1.69 centimeter per second. Our next question says a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at the rate of 2 feet per second. How fast is the top of the ladder moving down the wall when its base is 7 feet from the wall? Looking at the picture form, this is the house, or let's say the wall of the house, the wall, and then this will be our ladder, which is leaning against the wall. This ladder is 25 feet. Then we are given that, remember the question says how fast is the top of the ladder moving down the wall when its base is 7 feet from the wall. So the base is actually this side. This side is 7 feet. Now this ladder is being pulled this direction at the rate of 2 feet per second. So since it's been pulled on the horizontal direction, we can say this is dx over d time. And then the question says how fast is the top of the ladder, this top, moving down this direction when its base is. So it means you're looking for dy over dt. This is the information that we actually have. From here, we need to calculate this side. We can take it that we have a shape like this, which is 25, 7, we don't have this. We can use theorem of Pythagoras. X squared plus y squared is equals to r squared. We have x as 7 squared plus y squared is equals to r is 25 squared. Solving for y, we have y is equals to 25 squared minus 7 squared. Then we take the square root of this. We are going to have 24 feet. So updating the information, we have 24 feet here. Going back to the equation of theorem of Pythagoras, x squared plus y squared is equals to r squared. We go ahead and substitute the value of r, which is 25 squared. This will be equals to 625. And then taking the derivative of this with respect to t, we have 2x multiplied by dx over dt plus 2y multiplied by dy over dt equals to derivative of a constant is 0. Remember, we have the value of x, we have the value of y. X is equals to 7 feet, and then we know the rate of how this ladder is being pulled, which is 2 feet per second. So it's 2 plus 2y is 24 feet multiplied by dy over dt equals to 0. Transpose this to the other side, it becomes negative. So we have 224 dy over dt equals to negative 272. Divide both sides by 224. This will get rid of this. This will get rid of this. From here, dy over dt equals to negative. Let us number which is divisible into 2 and 24. It's 2. So on the numerator, you're left with 7 over 24 divided by 2. It's 12. And then the SI unit, it will be feet per second. So since it's negative, it indicates that the rate of this is actually decreasing. That is why it's negative. When it's increasing, it becomes positive. So this is the final answer. Well, that's it for this lesson video. We have lesson 103, which is also a practice question. This is Wahula SJ. Thank you very much.